Have you ever heard of the Arduino board? If so, have you ever wondered how some students are able to build and present impressive, flashy projects using Arduino in their school science fairs? Well, here's the answer. This is the first video in a series where I'll guide you through the basics of the Arduino board and show you step by step how to create cool school level projects. By the way, I'm Nevan Keri Meduri. I've recently completed the Montessori Kinder program and IGCSE exams. This coming July, I'll be starting my Cambridge A-level program. I was first introduced to Arduino in grade 7 as an extracurricular activity, and it sparked my interest so deeply that I've continued exploring it ever since. I began with simple projects like lighting up an LED, and over time, I've tackled more complex ones, such as building a quadcopter. Although the Arduino Uno isn't ideal for something as intricate as a quadcopter, it was a great learning tool. This is how an Arduino Uno board looks like. The Arduino website has very good documentation for all the required info. I always refer to the same. Basically, Arduino is an open source electronics platform based on easy to use hardware and software. Here one more question arises. What does open source mean? A simple meaning is that a hardware and software system where the design specifications such as schematics, layouts, and firmware, etc. are publicly available, allowing users to freely examine, modify, and depending on their requirements. So Arduino is also an open source platform. Arduino boards are able to read inputs like light on a sensor, a finger on a button, and turn it into an output, activating a motor, turning on an LED, publishing something online. You can tell your board what to do by sending a set of instructions to the microcontroller on the board. To do so, you use the Arduino programming language and the Arduino software called IDE, Integrated Development Environment. This is how it looks like. So again, what is a microcontroller? A microcontroller, MC, or microcontroller unit, MCU, is a small computer on a single integrated circuit. A microcontroller contains one or more CPUs, along with memory and programmable input-output peripherals. This is an Arduino Uno microcontroller. I have an Arduino Nano microcontroller. This is another microcontroller. And I also have an old microprocessor, the Intel P3. The main differences of a microcontroller and microprocessor are microcontrollers typically integrate CPU, memory, and input-output peripherals on a single chip, whereas microprocessors mainly consist of the CPU. Memory and peripherals are external. Microcontrollers also have a lower processing power because they're optimized for specific tasks, whereas microprocessors have a higher processing power as they are suited for more complex and general computing. Microcontrollers generally are cheaper due to the integration and lower complexity, but microprocessors are more expensive due to external components and higher capabilities. Microcontrollers consume less power, which makes them suitable for battery operated devices, whereas microprocessors consume more power, so they usually require more cooling and higher energy supply. Microcontrollers are used in automatically controlled products and devices such as automobile engines, control systems, implantable medical devices, remote controls, office machines, appliances, power tools, toys, and other embedded systems. By reducing the size and cost compared to a design that uses a separate microprocessor, memory, and input-output devices, microcontrollers make digital control of more devices and processes practical. Let's come back to Arduino. The brief history goes like this. It was invented in 2005 at the Ivrea Interaction Design Institute, Italy, as an easy tool for fast prototyping, aimed at students without a background in electronics and programming. As soon as it reached a wider community, the Arduino board started evolving from simple 8-bit boards to usage in products for IoT applications, wearables, 3D printing, and embedded environments. Why Arduino? So there are many reasons why Arduino gained its popularity from amateurs to professionals. Arduino software is easy to use for beginners, yet flexible enough for advanced users. It runs on all major operating systems, including Mac, Windows, and Linux. Arduino is low cost, and the Arduino software is published as open source tools available for extension by experienced programmers. The language can be expanded through C++ libraries, and people wanting to understand the technical details can shift from Arduino to the AVRC programming, on which it's based. We can also add AVRC code directly into our Arduino programs if required. The plans of the Arduino boards are published under a Creative Commons license, so experienced circuit designers can make their own version of the module, extending it and improving it. So this is the brief intro about the Arduino board. In the next video, we will understand how many types of Arduino boards are there. Till then, see you all and goodbye.